Alright, welcome to our first video. The first unit of physics is going to be kinematics. And what is kinematics? Well, kinematics is the branch of physics that is concerned to movement. What it causes that movement? Well, it doesn't matter here. We are only going to study that movement. Well, there are 6 topics in this unit, and the first one is the displacement. So let's focus on that one. Well, I hope you could see the SpongeBob SquarePants episode, and in displacement we are going to see 3 concepts that are very similar. Those are distance, displacement, and magnitude of the displacement. And what do they mean, and what is the difference between them? Let's start with the distance. As you remember, in the episode of SpongeBob SquarePants, they started from Krusty Krab. They drove the car in reverse a long path. After that, they lost the car and they had to walk. And after that, a tornado took them and took them farther from they were. Then they had to walk once again, starving this time. Finally, they found a rock and they drove that rock to the customer's house. Alright, the distance is all what they traveled. Sorry about that. The distance is all what they traveled, starting from here, and well, all what they drove, or all what they walked. That is the distance. What is the displacement? Well, the displacement, it's just the straight line that unites the initial position, that is Krusty Krab, with the final position, the customer's house. That is the displacement. The displacement doesn't even care all what you have traveled. The displacement only cares about what is between the final position and the initial position in straight line. That's it. So it's a little bit easy to see it this way, but it's gonna be a little more complicated when we see it with the formulas, with the numbers and the exercises. So let's see the differences that they have. Let's start with the distance. And well, there is something good about the distance. Sorry about this. Distance is the total length of the path traveled between 2 positions. And how can you calculate it? Well, here it says that it doesn't have a formula. You just have to count all the meters, kilometers, miles traveled. There is no formula. You just have to count all the units traveled. So that is the distance. And what about the displacement? The displacement is the change in position of an object. This one, it has a formula, and it is delta x equals xf minus xi. What do they mean? Well, delta x means displacement, xf means final position, and xi initial position. So in order to get the displacement, you need to subtract final position minus initial position. And as you can see here, there is a subtraction here, and that means that sometimes the result could be negative and sometimes could be positive. If the result is negative, the object is at the left. If the result is positive, the object is at the right. Keep in mind this because it's a very important position. It's very important. It's not the same to say that you are at the right or the left or something. With time, we will see that if the result is negative, could mean that the object is at the west, and if it's positive, the object is at the east. But we will see that with exercises. And finally, there is a third concept, which is the magnitude of the displacement. But before take a look at this one, let's remember how can you get the displacement? Subtracting final position minus initial position. If you do that, you will get the displacement. This symbol here, delta x, means displacement. Alright? So let's go to the magnitude of the displacement. This one also has a formula. It's a little bit shorter, and it's absolute value of delta x. Those vertical bars mean absolute value. What is that? Well, let's suppose that calculating the displacement, let's work with a simple example. Here we are. Let's suppose that initial position, the final position, sorry, it was 3 meters. And initial position is, let's suppose, 2 meters. Let's calculate the displacement, and we will do 3 meters. Sorry about that, 3, it's awful, I know it. Minus 2 meters. 3 minus 2 equals 1 meter. So what am I going to do with that 1 meter? Well, I'm going to calculate the magnitude of the displacement. Let's remember, in our example, the displacement is equal to 1 meter. And now I want to calculate the magnitude of the displacement. So I will replace between those two vertical bars 1 meter. And the absolute value of 1 meter, how much it is? Well, it's very easy. The absolute value of every positive number is the same number. That's it. Easy peasy. Nothing to do here. So it's not very complicated. But what if the result of the displacement is negative? Let's go back to the previous example. Let's suppose that now the final position is 3 meters and the initial position it's 4 meters. I make the subtraction, 3 meters minus 4 meters, and I will get a result of minus 1. Displacement equals minus 1. What I'm going to do here? Well, the absolute value of the displacement, that is the magnitude of the displacement, is the absolute value of minus 1. And how much is the absolute value of minus 1? How much it could be? Well, the answer is quite simple. Just 1. What that does it mean? The absolute value of every number, it's always going to be positive. So it's very easy to calculate that one. Perhaps the most difficult one could be the displacement, where you have to subtract. Not a big deal. So, well, with that, I think we have enough. We have the 3 concepts of this unit. So that's all for this video. In next videos, we will see what are all of those concepts about. So that's it for today, and I'll see you in the next video. Goodbye.